Today we're going to talk about how to simplify a radical, both a square root and a cube root, that isn't perfect. And we're also going to talk about addition and subtraction of radicals that are like radicals. As I go through the example problems, I'm going to focus on the odd numbered problems, and I'm going to leave the even numbers for you to practice or try in class, depending on the situation. So in number 1, we're going to simplify the square root of 512. There's a couple different methods for doing this. I was taught to look for the perfect square numbers that are inside of 512, those factors, but that can be kind of tough to do when it's a larger number. So I found that it's easier for a lot of people to just use prime factorization to break down 512 and look for things that show up twice. So why am I looking for things that show up twice? Because even though you don't see the index number of 2 right here, square roots are identifying things that have been squared. And squaring something means you multiply it times itself, therefore creating a group of 2. So when we break down the number 512, and I said to prime factor, you're going to use numbers like 2, 3, 5, 7, 11, so forth. How do you know where to begin? If the number is an even number, I'm going to start by dividing by 2. And this particular number can be divided by 2 a whole lot. If you're unsure how to divide by 2, it is fine for you to grab your calculator and use that as we go. 2 goes into 512 256 times. 2 into 256 is 128. 2 into 128 is 64. 2 into 64 is 32. 2 into 32 is 16. 2 into 16 is 8. 2 into 8 is 4. 2 into 4 is 2. And then finally, 2 into 2 is 1. And so I know I'm done when I get down to the number 1. So I'm going to circle things that show up twice because I'm looking for squares. Every one of these circles represents a perfect square. 2 times 2 is 4. The square root of 4 is 2. Every perfect square gets to come outside of the radical. And when it comes outside of the radical, it's going to multiply with anything else that gets to come out. And you can see I've got 1, 2, 3, 4 2s that get to come outside. They're going to multiply together. Anything that is not circled has to stay inside of the radical. When I multiply these 2's together, I get 16, square root of 2, and that is my final simplest form answer. Cube roots, the method for that is very similar. The only difference is instead of circling groups of 2, you're going to circle groups of 3. And we know that because a cube root means that a number has been multiplied times itself 3 times. If you have a positive number underneath a cube root, you will have a positive answer. But in this case, we're taking the cube root of a negative number, so I'm going to have a negative answer. When I break down 24, I get 2 times 12. 2 goes into 12 6 times. 2 goes into 6 3, and 3 goes into 3 1 time. And so there's my prime factors. Like I said before, I'm looking for something that shows up 3 times. So a 2 gets to come out, and a 3 is going to stay on the inside. When we get down to 5 and 7, the key difference with these two problems is that we have introduced variables. I've gone ahead and pre-factored number 5, just so we don't have to go through that process. You can see I've already circled the things that show up twice. And so 2 times 2 is what's going to get to come out. And a 2 will remain inside. Now, as far as the variables, you can see I've written out what the variables are if I expand them. Each of these exponents tells me how many times I have that variable. So I've got 2 x's and I have 3 y's. I can do the circling method for these also, and I can see what will come out and what is going to stay inside. Now, I didn't leave enough room here, so I'm going to rewrite this, but 2 times 2 is 4 on the outside. An x will get to come out, and a y is going to get to come out, so I'm going to write those down on the outside. And then I've got this 2 underneath the radical, and this y that wasn't circled. This would be my final simplest form answer. All right, on number 7, I'm going to show you a different technique for simplifying those variables. I've gone ahead and I've broken down 128, as you can see here. I'm going to go ahead and circle right now anything that shows up twice because this is a square root. And I can see that I'm going to have 1, 2, 3 2's that come outside of the radical, and I'm going to have 1, 2 that's going to stay inside. As far as the variables, I can write them out just like I did last time, but there is a little bit of a shortcut that we can use by using the index number and dividing it. We're looking for groups of 2, which is the same as dividing by 2. So if I do a division, 2 into the exponent, 2 divides into 3. I'm just going to do that right here so you can see. If I say 2 divides into 3, it will go in 1 time with 1 left over. So this tells me exactly how many come out and how many stay in. So 1 m will come out and 1 m will stay inside. I can do that with this one also. 2 divides into 2, 1 time with no leftovers. When would this be most beneficial? If your exponents are really large. You're not going to want to have to write out 50 x's and try to circle all the groups of 2. It's a lot easier to just say 2 goes into 50 25 times. Therefore, 25 would come out and none would stay inside. All right, number 9. Now we've got some fractional exponents, some rational exponents. These are just radicals. What you need to know is that the top number represents a power or an exponent, and the bottom number represents what type of root. So if you want to rewrite this, you can. This is just saying that we're taking the square root of 81 raised to the first power. If something is raised to the first power, you don't need to write the power of 1 because anything raised to the first power is going to remain the same. The square root of 81 is a perfect square. So I can go ahead and just write down that answer and I am done. In number 11, you're going to notice that there is a top number larger than 1. So I am going to have to deal with it this time. The bottom number tells me that I do have a square root, and it's going to be raised to the third power. So the way I would set this up, I would take the square root of 100 first, and then after I figure out what the square root of 100 is, I would raise that answer to the third power. The square root of 100 is 10, and then 10 raised to the third power is 1,000. Whoops, there we go. And so that's my final answer. Again, you're welcome to use your calculator on some of these. It might help just go through things a little bit easier. 13 and 15. And these we're going to combine radicals that are alike. So what makes a radical alike? It has to be the same type of radical, meaning it has to be a square root with a square root, or a cube root with a cube root. But not only does it have to be the same type of radical, it has to have the same number underneath the radical. So, one of the things that you're going to want to do on these problems is simplify, just like we did before, if possible. Well, 2 is prime, so I know that's not going to simplify any further. Same here. 6, if I break down 6, it only breaks down into 2 times 3. Nothing shows up twice, therefore nothing's going to come out. So this would be considered simplest form also. The only 2 radicals in this problem that I'm going to be able to combine are the first 2. They are both the square root of 2, square root of 2. When you combine radicals, you only combine the numbers in front, your coefficients. So when I put a negative 3 with a negative 2, since they have the same sign, we're going to add them and keep the sign, which is negative 5. And the radical is going to remain the same. And I'm going to bring this radical down because I could not combine it, and we're just going to write them side by side. This is my final answer for number 13. Number 15. This problem is going to require a little bit of simplification before we can do our combination. The first radical is in simplest form, but 27 can break down. I'm going to do that out here to the side. 27 is not an even number, so I'm not going to divide by 2. I'm going to try 3. 3 will go into 27 9 times. 9 is also divisible by 3, so 3 goes into 9 3 times, and then 3 goes into 3 1 time. Since this is a square root, I'm looking for things that show up twice. So a 3 is going to get to come out of this radical. Now here's one of the things I want you to notice. There was already a 3 out here. So when a number comes out of a radical, it is going to multiply with any numbers that are already out there. So this 3 times 3 is going to become 9. And this 3 remains inside. So this is the new radical. It is also positive, so I'll go ahead and write that plus sign. I'm going to bring down my negative 2 square root of 2, and I've rewritten this part. All right, 12. 12 can also break down. 2 goes into 12 6 times, 2 into 6, 3, and 3 into 3, 1. Anything that shows up twice gets to come out. So a 2 is going to come out. It's going to multiply with the negative 2 that was already out here. That's going to give me negative 4. This 3 will remain inside, so now I can cross this out. All right, so now that I've simplified everything, I can combine the 2 radicals that are considered to be like radicals, and that would be these 2. When I do my combination, I'm only going to combine the coefficients, positive 9, negative 4, which gives me a positive 5. So I'm going to write down negative 2 square root of 2 plus 5 square root of 3. And that is my final answer.